All right, here we are in chapter 13, exponential and logarithmic functions. So the last section for this chapter is 13.4. We're going to look at solving exponential and logarithmic equations. So solving logarithmic equations with common bases is how we're going to look at this first. And so if we have a, which is the base, and then m and n, which are just values, are all greater than 0, and a cannot equal 1, then we have log base a of m is equal to log base a of n, implies that our m is equal to our n. Okay, so the key is we have to have same bases, and then what we can do is we can set the m equal to n. And we're going to use logarithm properties to simplify expressions within an equation prior to solving it. So sometimes before we get to the point where we have one log is equal to another log, we might have 3 or 4 over here that we have to combine using the different properties of logarithms, and then we get it down to the final one, and then we can set those equal. Now, if we have exponential equations, what we're going to have to do is convert those to logarithmic form first, and then solve the equation after that. So those are the kind of key things we need here. And so let's look at just starting to solve some equations. So on the left, you notice we have two logs here, log base e or ln, and we only have one on the right, and we have to have one on each side. And so what we're going to do is we're going to combine these two using our properties, and because it's negative, that means it's going to divide. So that's going to give us ln of 60 over x equals ln of x, and then that's a minus 4. Let's just erase that. All right, so minus 4, okay? Now we can use the property where they have the same base, which in this case is base e. We just set each of those equal to each other and simplify. So that gives us 60 over x equals x minus 4. Now if we take and get rid of this and we multiply this side by x, and we multiply this side by x, we get 60 equals x squared minus 4x. Now, now we see this as the quadratic if we subtract 60 here. And so that gives us x squared minus 4x minus 60 equals 0. Now we just have to factor and then set each of these factors equal to 0 and solve for x. So what two factors of 60 will subtract to give us 4? Well, if you think about it, 10 and 6 give us 60. And so we'll have x and x, 10 and 6. 10 minus 6 is 4. Well, I need the larger one to be negative, so that has to be the 10. That means that one's positive. Now, if I set this equal to 0, x is equal to 10. If I set this one equal to 0, x equals negative 6. Now, what do we know about signs of these? Well, we can't have negatives. We can't take the ln of a negative. And so we can't have that one. And so the only possible solution is x is equal to 10. And so that would be our answer. What about here? Now, this time we have an addition between the two. So that means we're going to multiply when we add them together, or put the two logarithms together. So we'll have log, and it's going to be of x times x plus 1 equals log of 72. Well, x times x plus 1 is going to give us log of x squared plus x equals log of 72. And now we can say, well, this is equal to that because we have the same logs on both sides. And so x squared plus x equals 72. Now we're going to do the same kind of thing as we did on the last one. We're going to have x squared plus x minus 72 equals 0. Now what two factors of 72, if you subtract and give us 1, 9 times 8 I think should work. So x plus 9 and x minus 8, because we need a positive 1 here. And so if we set that, that's x equals negative 9, and here we get x equals 8. Doing the same thing, we just set that whole thing equal to 0, subtract 9 from both sides, and we get 9, that's negative. And here we set that, and the 8 goes over and it becomes positive. And same thing here, we can't have a negative. So the only solution then is x equals 8. All right, so that's the first couple of examples. Let's look at some more here. Okay, so same thing is going on here and here. And the key to note is, remember what we have here. That's a 3, this is a 2, but what we can do is say, well, that's going to be, if we take that times 1, what is 1 here? Well, that's going to be log base 10 of 10. Remember, that's just a given 10 when we have these. We just drop it, but that's log base 10 of 10, which is 1. And so now what we can do is we can say, okay, well, that goes up here, and so now we have log, and when we have the subtraction on this side, that's going to become a division, so it's 3x minus 8 over 9x, and that equals log of 10 squared. Okay, so what we did is we just took the 2 up here. Now we've got a log here, so we can just set this equal to this. So we have 3x minus 8 over 9x equals, well, 10 squared, that's just 100. Okay. So now what do we have? Well, I'm going to multiply both sides by 9x to get rid of that in the denominator. So I have 3x minus 8 equals 900x. Well, let's subtract 3x. And so we get a negative 8 equals, and that's 897x. So divide by 897, divide by 897. So x is equal to a negative 8 over 897. Okay. Now, what does that mean? Well, that's a negative. And if we have a negative here and multiply, that's going to give us a negative. So that is not a solution. So that means we have no solution to this one because we can't end up with the negative value for taking a log. Okay. Well, what does this one do on the right? Well, in this one, we have log base 5. So that's going to be log base 5 of 5. Okay. And then we're going to have to take that up here. And so now we have, again, a difference. So it's going to be log base 5 of x plus 2 over x minus 3 equals log base 5 of 5 to the third. Now we've got log base 5, so we can set that equal to that. And 5 times 5 is 25, times 5 more is 125. And so what I'm going to do now is multiply both sides by x minus 3. And so on the left, those cancel, and I get x plus 2 equals 125x, and then minus, and that's going to be 375. All right, let's add 375, and let's subtract x. So 375 plus 2 is 377, and that is equal to 124x divided by 124, divided by 124. So x equals 377 over 124, and I don't think that can be reduced, and so therefore our final solution is just 377 over 124. All right, here we go. The first one, that's pretty easy. Basically, we have the log base 8 and log base 8 are the same, so we just say x is equal to 6, and we're done. So sometimes works out really nice. But then again, the next one's not as easy. So the last time we saw this, we had to multiply by log base, in this case 11 of 11. And then that 1 we're going to take up there, but it's just an implied 1, and so we could just drop it. This side we have addition of the 2, so that means we're going to multiply. So that's going to give us log base 11 of, now we have x times that, so we'll have x times 5x minus 6. I guess if we put all that in parentheses, that equals log base 11 of 11. All right, so what are we going to do here? Well, what we can do is we can say, well, that is equal to that because we have the same log base. And so if we distribute here as we take it out, that's going to give us a 5x squared minus 6x equals, and on this side we just have 11. So subtract 11, and then we have 5x squared minus 6x minus 11 equals 0. And now we have to factor. So factors of 5 are just 5x and x. 11 are just 11 and 1. If we do 11 here, that's 55. I think we'll put 11 here, 1 here. So 11 minus 5 is 6. We need it negative, so that's a negative. That's a positive. So set that equal to 0 and set that equal to 0. So x is equal to negative 1. That one's gone. So add 11. 5x equals 11. Divide by 5. X equals 11 over 5. And so that would be our solution. Again, we can't have a log of a negative number here, and so that one is canceled. Okay. So one here that wasn't too bad. One that was, pretty simple, x equals 6. All right, so here we're going to solve the equation, give an exact solution and an approximate solution to 4 decimal places. So we're actually going to have to plug it in to our calculator and see what it is. All right, so what are we going to do? So on this one, what we need to do is we need to think about our bases and our values and our exponents and kind of go from there. So our exponent is x plus 7, our base is 3, and our value is that. So it's going to be log base 3 of 7 equals x plus 7. Now, if you don't remember, then 3 to that power equals 7, and that's what we have here. Now, let's see. We want to solve for x. So our x is here, so if we subtract 7, we get x equals log base 3 of 7 minus 7. So this is our exact value, okay? So that's the first one they want. And then they want the approximate solution to 4 decimal places. So, well, here we're going to have to convert this to change of base formula. So that's going to give us ln of 7 over ln of 3 minus 7. And so if we plug that into our calculator, let's go do that. So let's clear this. So we're going to have, I think I said ln of 7 divided by ln of 3. And then it was minus a 7. And so negative 52287 at 4 decimal places. So that 5 would round that to 8. So 2288. And so we get negative 5.2288. And so that is the approximate solution. So we need both of those, and that would be how we would simplify this. And again, we had to go to logs first, and then we could work with that and simplify. And that's what we're going to do here too. So this is our exponent, and so that's the right side. And then we have log base 2 of the value 3.6. Okay. Now, we need to solve for x. We have to divide by 8, basically. And so x is equal to log base 2 of 3.6. And then when we divide by 8, we could also say, well, let's multiply by 1/8. And so that way, we have just kind of continuous thing. We don't have this whole mess with a sub and then divided by 8. So that's what it would do. I would do for this one instead of having it divided by 8 there. I would have probably should have multiplied by 1/8. But that is going to be my exact solution. Now, the reason I did that was because I started thinking about when I do this change of base formula, I'm going to have fractions, and so I want to kind of have fractions times fractions. And so this is going to be 1/8 times, now I'm going to have ln of 3.6 over ln of 2. So just changing the base here to this, and now I can plug that into the calculator. And so that was going to be equal to 1 divided by 8 times ln of 3.6 divided by ln of 2. And so I get 0.23099. So that 9 rounds that 9 up to a 10, so we get 2310. So that gives us 0.2310 to 4 decimal places. So those are the exact and the approximate solutions. All right, so we're continuing on. We're getting exact and approximate solutions. And here, this doesn't have any factors of 2. So what I'm going to do is I'm going to divide by 10. I'm just going to get rid of that. So then I have 2 to the x equals basically 1.1. Divide that by 10, you just move the decimal once. Now I've got a base, I've got an exponent, and I've got the value. So now I can say, well, that's log base 2 of, and then it's 1.1 equals my exponent, which is x. 2 to the x equals 1.1. All right, well, that's my exact value. I don't even have to do any other work. That's the exact value. And now if I want the approximate, that's just going to be the ln of 1.1 over the ln of 2. Going back to our calculator, ln of 1.1 divided by ln of 2. We get 0.13750, so it's 1375. And so that would be my approximate solution. So my exact and my approximate. Okay. All right, so the next one is going to do the same thing, except here I had to divide on the first one. This one, I'm going to multiply both sides by 8. Okay. And so then I have 5 to the 9x equals, and then 4.9 times 8. I'm just going to do that on my other calculator here. 4.9 times 8. And that's 39.2. All right. So continuing on with that, now we're going to do just like we did before, and we're going to say, okay, well, we have log base 5 of 39.2 is equal to 9x. 5 to the 9x equals 39.2. Now I'm going to take and multiply by 1/9. And again, that's because I know I'm going to do a change of base formula here. And so x equals 1/9 of log base 5 of 39.2. So that would be my exact solution. Now my approximate solution is just going to be 1/9 times ln of 39.2 over ln of 5. And so if I go do that, all right, so we had, it was 1 divided by 9 times the ln of 39.2 divided by the ln of 5. And I get 0.2532, but that 7 rounds that up to a 3, so 2533. And then that would be my approximate solution for this one. Okay, and so that's, key things. You have to kind of get it to the point where you can have an exponential on one side only and then everything else on the other, and then just use your converting it to a log function, and then you can simplify from there. All right, so then we have some application problems here. So it says the half-life for thorium-227 is 18.72 days. The amount A in grams, so that's the key here, that's the number of grams of thorium-239 after T years is, for a 10-gram sample is given by this here formula. And I don't know why they changed things. It should probably still be 227 there, but that's what the book said, so I just left it. And so I'm going to actually change that, I think, to 227. And so here we have the formula. So A of T, which is the number of grams after time T, is 10 times 0.5 raised to the power T over 18.72. And it says, how long will it take before there are 4 grams of thorium left in the sample? Round your answers to the hundredths place, so 2 decimal places. Well, remember, A is in grams, so we have 4 grams is equal to 10 times 0.5 to the T over 18.72. Okay, so that's basically all we did was we plugged in the 4 here and wrote out the rest of the equation. Now we need to solve for T. Well, that's exactly what we were doing here. We had to solve for X in this case, but it's the same kind of thing. We have something multiplied by something to some power, and we're going to do the same thing here. So I'm going to divide both sides by 10. Now when I do that, those cancel. Now this reduces to 2 over 5. So I'm going to keep it as 2 over 5 in the next step. So 2 over 5 equals, and then I have 0.5 to the t over 18.72. Okay. Now what we need to do is it's going to be the log base 0.5 of, and now we're going to have 2/5, and that's equal to the t over 18.72. So we have 0.5 to the t over 18.72 equals 2/5. Okay, so that's kind of how we've been doing it. Now I'm going to multiply by 18.72, and I'm going to multiply by 18.72 because that gives me t. So t is equal to 18.72 times the log of base 0.5 of 2/5. Okay. Now remember, we have to use our change of base formula here. So that's going to be t equals 18.72 times, I'll use ln of, and now we have 2/5 over ln of 0.5. All right, so let's see what we get there. So let's clear that. So we had 18.72 times, and we had ln of, we had 2/5 divided by ln, and then we had our base, which was 0.5, and we get 24.746 to the nearest hundredth, which is 2 decimals. So that would round up to 24.75. So that's equal to 24.75. And this is going to be years, or days, sorry, days. Okay, because we're in days is going to be the half-life. And so in 24.75 days, we should get the correct value. Oh wait, t's in years. I was right the first time. I saw days was half-life. Okay, so let's go back here. I was right in years. Just have to believe in yourself. All right. So after t years, okay. So 24.75, and again, all it was just using our properties of logs and exponents and just arithmetic and working our way down until we could plug something into our calculator and get our answer. All right, what about the next one? So the next one says the formula y equals 1 plus 1.5 times ln of x plus 1 models the average number of free throws a basketball player can make consecutively during practice as a function of time, where x is the number of consecutive days that player has practiced for 2 hours. And so after how many days of practice can the basketball player make an average of 8 consecutive free throws? Well, that means we want y to be equal to 8. And so what we want to do is solve for x, which is going to be our time in days. So if we do that, we're going to have 8 equals 1 plus 1.5 ln of x plus 1. So I'm going to subtract 1. 7 equals 1.5 ln x plus 1. I'll divide by 1.5. And so now I have 7 over 1.5, and I'll just leave it as that for right now. And that's equal to the ln of x plus 1. Okay. Now, if you remember, this is log base e of e. Of whatever it is, I guess it's x plus 1. But if we take and raise this to that power with the same bases here, we get this out. And so I'm going to take e to that, but if I take e to that on this side, I have to take e to that on that side. So I have e to the 7 over 1.5 equals e to the ln x plus 1. Okay. So what does that give me? Well, that gives me on the right side x plus 1. On the left, I just get e to the 7 over 1.5, which we can type into our calculator, so that's not a problem. Now I just subtract 1 from both sides, and I get x equals e to the 7 over 1.5 minus 1. And now I have to plug that in my calculator to see what my answer is. So to kind of show you how that works, now our E button is associated with ln, so it's going to be right above it. And so it's going to be second E, and I had 7 divided by 1.5. Then I have to remember to arrow down, and then minus that 1, and that says 105.342. So I forget how many days it asked for. So 105.342. Doesn't say what to round it to, so we'll round it to the whole day. And so if we remember, it's 105.34, so that's approximately 105 days. Okay, so after 105 days of practicing for 2 hours a day consecutively, then they can make an average of 8 consecutive free throws. Okay, so a lot of days to get to that point. All right, what about the next one? The next one says we have Newton's law of cooling states that the temperature of a heated object decreases exponentially over time toward the temperature of the surrounding medium. Suppose that a coffee is served at a temperature of 143 degrees Fahrenheit and placed in a room whose temperature is 70 degrees Fahrenheit. The temperature mu in degrees Fahrenheit of the coffee at time t in minutes can be modeled by mu of t equals 70 plus 73 times e to the negative 0.07 t. And it asks, when will the temperature be 105 degrees Fahrenheit? Now remember, that's what is mu. So we're going to replace mu of t with 105. So 105 equals 70 plus 73 e to the negative 0.07 t. And we want to solve for time in minutes. All right, so what do? Well, we first subtract 70. And so that's going to give us what? 3 equals 73 e to the negative 0.07 t. Now we're going to divide by 73. Now that cancels, and I'm just going to leave it as that. So I'm going to have 35 over 73 equals e to negative 0.07 t. Now, remember, if we take the ln of this is a power, so it goes down in front, and the ln of e is 1, because remember, ln of e is equal to the log base e of e, and that's just 1. So I'm going to now take ln of both sides. Okay. Now remember, this will come down front, so I get ln of 35 over 73 equals negative 0.07 t times ln of e, which is 1. Okay. Now I need to divide both sides by negative 0.07. And so t equals, and that's the, let's write it out so I can read it here, 35 over 73 divided by negative 0.07. And so now we need to plug that into our calculator. So what do we get there? So we're going to have the ln of 35 divided by 73. And notice we don't have to do any conversion factors to convert because we have ln's. We don't have to do any base changes. And then that was divided by a negative 0.07. And so that gives us 10.50. And it was in minutes. Does it say decimals? No. So let's say that that's equal to 10.5 minutes. So basically 10.5 minutes will be down to 105 from the 143. And so that's going to be how long it takes. Okay. And so let's do one last one here. And so it says, according to the U.S. Census Bureau, the population of the U.S. in 2008 was 304 million people. In addition, the population of the U.S. was growing at a rate of 1.1% per year. Now, assuming this growth rate is continuous, then the following model is going to be true. So P of t, which is population P in millions of people is equal to 304 times 1.011. That's our growth rate, raised to the power T minus 2008. So time from 2008. All right, so T when we get done is going to be in a year, so 2035, 2040, I don't know, whatever we're getting to. And so according to the model, when will the population be 404 million people? So we're going to plug in just 404 because remember this is in millions, and so we're just going to say 404 equals 304 times 1.011 to the T minus 2008. All right, so how do we solve this? Well, we need to get rid of that 304 first. And so then we have 404 over 304. And notice I don't simplify this until I plug it into the final calculation. And that equals 1.011 and then T minus 2008. Okay. Now, here what I want to do is I want to get rid of this exponent. And so I'm going to take the ln of both sides. Okay. Now when I do that, that means this can come down front, and I get ln of 404 over 304. That's a 4. And that is equal to T minus 2008. And then that's times ln of 1.011. Okay. Now we have to divide by that ln. So we're going to divide all that. Ln of 1.011 divide by ln of 1.011. And so now we have T minus 2008 equals, and then we have the ln of 404 over 304 divided by ln of 1.011. Now I need to get rid of the 2008, so I'm going to add 2008 to both sides. And so T is equal to ln of 404 over 304 over ln of 1.011 plus 2008. So now I need to plug that into my calculator. All right, so let's clear that. So then we had ln of 404 divided by 304 divided by ln 1.011. And then after that, we added 2008. And we get 2033.995. So no matter what, this is rounding up to 2034. And since I believe this was in years, this is going to be approximately 2034. So that's the year it's going to hit 404 million people. Okay. All right, so that's all I have for section 13.4. So hopefully that will help you.